Welcome students. We have seen binomial distribution and we have seen Poisson distribution. So any quantity whose variation depends on random causes can be distributed as normal distribution or what we call as Gaussian distribution. The only limiting case here is that n should be very large. That is, in case of binomial distribution, we have n, c, r, p, r, q, and n minus r. You know all these terms. When the number of events is very large and the quantity has variation as per random causes, the distribution will be normal. That is, the curve will be normal. What we do here is, we take a variate z that is given by x minus np under root npq. X is the binomial variate and np is what? Mean. You know this from binomial distribution. You can see the constants of binomial distribution. np is mean and under root npq is standard deviation. You should always keep this in mind. M is np, standard deviation is under root npq. So we define a variate which is x minus np by under root npq. X is the binomial variate. So x takes discrete values. Now if you see this particular function, for all discrete values of x, z becomes continuous. That is, if x tends to infinity, we will have z from minus infinity to infinity. Therefore, the discrete distribution essentially becomes continuous distribution. Clear? One thing should be kept in mind, that in Poisson distribution, our limiting case was p tends to 0 in Poisson distribution. Here, p and q both have significant values. Neither p is very small nor q is very small. Similarly, neither p is very high nor q is very high. The normal curve is of the form fx, that is our y, given by 1 by sigma root over 2 pi e to the power minus x minus mu square by 2 sigma square. What is sigma? We know it is standard deviation. And what is mu? It is mean. So the normal curve given by this function can be plotted like this. What is this? This is unimodal. The first property is this curve is unimodal. That is, we have only one mode here. See, and you know, in this case, mean, median, mode all will be at this point only. So this is x equal to mu, mean. So what is the value of y? And the maximum value of y for x equal to mu, it will be for x equal to mu because the peak is at x equal to mu. So what is this value? When you will put x equal to mu here, this becomes 0. So this will be 1. So that value, the maximum value of this is 1 by sigma 2 pi. Clear? Now the points of inflection in this curve. How do we find point of inflection? We take d2y by dx2 equal to 0. That is, we will take second derivative of this function, equate it to 0, and we will check that d3y by dx3 is not equal to 0. So when these conditions are met, when we will solve this equation, we will get the points of inflection, and that will be x equal to mu plus minus sigma. That is minus sigma to plus sigma. These are the points of inflection. So our normal curve is unimodal and it is symmetrical about this axis. That is 50. The area covered by this part and this part are equal. Now let's see first, that is mean deviation from the mean. Mean deviation from mean. What is mean? Mu. So how we find this? This will be equal to, this is given by, if you remember, if you have studied moment generating functions, how we take it? This is minus infinity to infinity, the function that is y into x mode of x minus mu dx. So we'll put the value of what is y? Y is 1 by sigma root over 2 pi e to the power minus x minus mu square by 2 sigma square. So what we do? We put this value, we take the integration. What you will find that this value comes to 4 by 5 of approximately 4 by 5 of sigma, that is the standard deviation. So I am writing it here. First, mean deviation from mean is given by 4 by 5 of sigma. What I am trying to say is that you don't need to derive every formula. What you need to remember is this. You have to remember the results only. So I am writing the results at one place. Second is moments about the mean. How do we take moments about the mean? What we do? We simply integrate from minus infinity to infinity x minus mu to the power, if we say this is the nth moment. So this to the power n into the function, that is function is 1 by sigma root 2 pi e to the power minus x minus mu square by 2 sigma square dx. This is this. So what are the moments about the mean? When you will do the mathematics, when you will do the derivation and all, what you will find is there are two types of moments. First is the odd moments and second is the even moments. That is, this will give mu 3, mu 5, mu 7 and all, and this will give mu 2, mu 4, mu 6, mu 8 and all. What you will see that the odd moments are 0. That is mu 3, mu 5, mu 7 and so on, all are 0 in case of normal curve. And this you will get 2n minus 1, 2n minus 3 up to 3, 1 and then sigma to the power 2n. This will be the value of the even moments. Particularly, if you will put the value of n equal to 1, what you will get? That is mu 2. Mu 2 will be sigma square. Mu 4 will be mu 4. 2 will put to the value 2. Clear? So this will become 3 sigma to the power 4. And we have all the mu 3, all the odd ones, 3, 5, 7 and all 0. Clear? Now what is beta 1? It is mu 3 square by mu 2 cube. Mu 3 is 0, so beta 1 is 0. And what is beta 2? It is mu 4 by mu 2 square. What is mu 4? It is 3 sigma 4. And what is mu 2? Mu 2 is sigma square. See, mu 2 is sigma square. So this will be sigma 4. This cancels. So beta 2 is 3. So what do we get from here? This means beta 1 is 0, that is skewness is 0. Skewness is 0. This means the curve is symmetrical. Clear? So from here only we have defined that symmetrical curves have beta 1 equal to 0 and beta 2 is equal to 3. What does it mean? And beta 2 is 3, that is kurtosis is 3. Therefore we had taken the values of beta 2 greater than 3, beta 2 less than 3 and beta 2 equal to 3. Our definition was based on 3 only. So that whether it is leptokurtic, or it is mesokurtic or it is platykurtic. So we had defined it on the basis of this particular value 3. Clear?